Hey everyone, Kumar here. Today's topic is how Bayesian optimization thinks, smarter experiments through uncertainty. In formulation R&D, the stakes are high. You're balancing shelf life, cost, regulatory constraints, and consumer liking, often with limited data and tight timelines. You can't afford to run every possible experiment. That's where Bayesian optimization shines. It turns uncertainty into a strategic advantage. Modeling uncertainty as distributions, not just predictions. Most formulators are used to point estimates, like this version is expected to score a 7.2 in stability. But Bayesian optimization says, hold on, that's not enough. Instead, it asks, how sure are we that it's a 7.2? It models every formulation as a bell-shaped curve, predicting not just a score, but a range of possibilities based on what we know. Think of it like this. Let's say you're checking the weather. Would you rather hear it'll be 75 Fahrenheit tomorrow, or it'll be between 72 and 78 with a 90% confidence? That range changes how you pack, plan, or dress. Similarly, modeling uncertainty helps you plan your next experiment more intelligently. In the real world, let's say you're doing infant formula development, where over-fortifying with iron affects bioavailability and taste, knowing the uncertainty range around mineral interactions is just as critical as knowing the average outcome. Learning from data, each experiment reshapes the landscape. Bayesian optimization isn't static. It learns with every test. When you run a new formulation, you're not just checking a box. You're reshaping the model's belief about the entire design space. Where you've sampled, the model becomes confident. Its uncertainty flattens. But in regions you haven't tested, it still allows for surprise. Uncertainty remains high. Think of a treasure map where fog covers most of the terrain. Every experiment is like lighting a torch that clears a bit of fog. The more torches you light in the right places, the faster you reveal where the treasure really is. In an example, in a clean label emulsions, the interaction between emulsifier percentage, oil percentage, and mixing speed often behaves non-linearly. A single experiment in the right spot can teach the model about an entire region of the design space, accelerating discovery far beyond brute force screening. Strategic experimentation, balancing exploration and exploitation. Bayesian optimization uses acquisition functions to decide what's the smartest next move. It looks at both the predicted performance, mean, and the uncertainty, standard deviation, at each point. The question it's really asking is, where can I learn the most or find something better than what I've already seen? Imagine being a new city with one great restaurant you've tried. Do you keep going back or explore others that might be even better? A good strategy mixes both. That's exactly what Bayesian optimization does. It balances safe bets with high potential unknowns. As an example, in flavor system design, where interactions between acidulants, sweeteners, and natural extracts can produce surprising results, this strategy helps teams uncover optimal zones faster and with fewer trials, reducing waste, labor, and cost. Final thought. Bayesian optimization redefines what it means to run a smart R&D program. It doesn't just guide you to what's working. It shows you how confident you can be, where your blind spots are, and where the next big win might be hiding. It's not magic. It's a scientific framework for strategic learning in complex, high-dimensional spaces. If you're building the next generation of high-performance, cost-effective, or regulatory-compliant formulations, this mindset shift can unlock massive efficiency gains in your R&D pipeline. Subscribe for more on how AI and probabilistic modeling are transforming product innovation. Thank you.